Okay, I want to make sure you guys definitely understand that to test this tomorrow. This is the test itself. I have it right in front of me, so I'm going to kind of tell you what's going to be on it, what's not. Number 1 has 2 parts. 2 has only 1. 3 has 1. 4 has 1. 5 has 1 part. 6 is probably the longest one, which has 5 parts to it. It's your side angle, side. You're just marking them, so they're not that difficult. 7, 8, 9, 10 all have 1 part. Okay, so they're not that tricky to understand. And even 11 has only 1 part. They're very doable. You guys have to realize that the test is much harder than, or the team test is much harder than the test. And I make them specifically that way because if you can ace the team test, you can ace the test. Okay? So that's the feel you guys should be able to get from it. Here's the first part. Take a look at those. Yes. Not congruent is fine. Yes. SAA is still fine. Yep. Yep. Yes. HL was not one that we covered. Don't worry about what HL is. HL is another acronym. It's for hypotenuse leg. It's another kind of angle congruence, but it contradicts angle side side. It is another one you can use, but the same can be considered. Hypotenuse leg can still be done by side angle side. So it still can be done. Okay. So don't worry about that. That wasn't the one we covered already, so don't worry about it. 1 through 12 at all? Checking them out. 1 through 12. Going once? Going twice? You cannot use AAA or ASS or the reverse of that, which is SSA. We'll cover that a little bit as well. Side angle does not work. Okay, look at the bottom ones here. Now, what you're getting for number 13 came very similar from what we actually did on the actual practice of equilateral triangles. You're given to this on the back side, I believe, on it, or the bottom two. It gives you a property where all 3 sides are congruent. If you know that all 3 sides are congruent, that means you could set all 3 sides equal to each other. As long as you set one pair equal, it should be able to give you the correct answer. For my problem here, I did the side 2, so 3x plus 6, 9x minus 12, and I set them equal to each other. When you solve this out, you're going to get x is equal to 3, but that's not what it's asking for. It's asking us for any of the side lengths. So I plugged in to my first 3x plus 6 to get 15. You can do it to any of them. 3 times 9 is 27. 27 minus 12 is 15. 3 times 6 is 18. 18 minus 3 is 15. 3 times 3 is 9, plus 6 is 15. So no matter where you plug it in at, you're going to get the same value. Okay. There are essentially 3 different ways you could probably solve for this. But you want to be able to know that equilateral triangle corollary or whatever tells you that if the angles are congruent, the sides are congruent. And if the sides are congruent, that means the angles are congruent. Okay, given an equilateral triangle. Okay. Number 14 from here, what I did with this is I actually did process of elimination. My first process here was KA or KLJ. So I'm going to K to L, K to L, L to J. Okay. If I do it to the other one, M to L, M to N, N to L, N to M, N to L, sets it up incorrectly, not the first pair. If I do the second one, which is down below, J to L, JL, and L, not the same setup. Do the third pair, JK. So J to K goes on my third side first. M to N goes to the second pair first. So the only one that really works this out is our last pair. Another way you could have done it is you could have noticed that J, so I'm going to kind of erase this part right here. You could have just gone by the actual letters themselves. J corresponds with M, J with M. They're in the middle of those two and 3. K with N is between 3 and 1. And our last pair, which is L and L, which is the same part. Either way would have worked. The process of what you do is done by CPCTC, right? Corresponding parts are congruent. I think it is. I think it is, absolutely. Yeah. Yep. Your call, though. Your call. Some people find the other way to do it is easier. It's just up to you. The bottom portion is a very tricky and long one. Okay, like I said before, they're meant to be long. If I'm showing you the ones for the test, you have 2 of them on the bottom right here. You have 1 here and 1 here. Okay, they're more simple. Okay, these are more complex. I get that. Okay, but the process and solving are still done the exact same way. Okay, I have all the equations up here, and I'm going to show you how I've done them. The first pair that I'm getting right here is solving for angle 1 by doing the exterior angle theorem. So I'm doing all of these for the first pair. Okay, that's alternate exterior angle theorem. The next thing I did with this is I know that this part was vertical. So this makes this little angle 36. The next pair I did is I knew that this angle right here was supplementary. So 70 plus angle 4 plus 65 is equal to 180. Okay, draw this in. I also knew that the other pair right here was also supplementary. Angle 4 happens to be 45. So I'm going to put that in. 70 plus 45 is equal to angle 3. You could have also known that 35 and 65 are vertical to get that one as well. Angle 3 and 65 are vertical. It's another way to do it. They form an X. Okay. Because I knew angle 3 and 36, I add them up to get angle 2, which is this triangle right here, triangle sum theorem, to give me my part for number 2. Simplifying this out, I know I have alternate exterior angle theorem for this by doing, for number 5, angle 4 plus angle 5 is equal to the exterior angle right here. So it would have been 45 plus angle 5 is equal to 180. Where did I get that one? 45 plus angle 5. 45 plus angle 5. Is that one bad? That one's bad. Supplementary with which pair? This angle right here? Yeah, you could have done that and then solved it out the same way. What's 118 minus 45? Can someone have a calculator out there? 45? I think angle 5 is wrong. What is it? 73. Yeah. It should have been 118. That should have been 118. No. It just changes angle 5. Okay. And the last part of this is to do these triangle sum again For the bottom portion to get angle 6. So 65 and 82 is equal to angle 6. Louder, louder. Angle 5. Another way to say that angle as well would have been to say angle 4 plus angle 5 is equal to 118. And I know angle 4 to be 45. So that's where this equation is getting from. To get angle 5, yes. Questions on the front side at all? This one? Angle 6 would be whatever angle 6 is subtracting from 47, so 23, I want to say. 33? 33. 33.
So that's 30.
Okay. Questions at all so far? Yes. Number 5? Angle 5, yes. In this case, my angle 5, I'm going to kind of bold this up a little bit. Our angle 5 happens to be from here, right? Triangle sum would have worked for this if you know that this was 118 subtracting that. You could have also known alternate exterior angle theorem. So this is 45 plus 5 is equal to the exterior angle 118. Is that good? Flipping it over to the back side. Do not worry about 16. Do not put it on your card. It was a typo. That should have been a different problem, I realized. Okay. We still solved it good. It was consecutive interior. It means they add up to 180. When you solve out, you're going to get x is equal to 4. Don't worry about that problem if you didn't do it. Okay, you will not have one on your test. Okay, it should have been a different problem that I realize now. Check 17, 18, and 19. I'll go ahead and do a couple of them. Actually, I'll do all of them. I'm sorry, one more time? Yes. Hold on. I'm going to do them. After you have questions, I'll take questions after. Let me do it first. Okay, I'm seeing you guys finishing up. Now, 17. 17 definitely involves CPCTC. Okay? It's not triangles, but it's parts. What I want you guys to see from here, as long as you're able to see that polygon BCDE and RSTU are congruent, you're going to be able to say some stuff about them. The first part that we want to be able to see here is solving for W, which happens to be that BC would be congruent to RS. Since those two are congruent, we can set them equal and solve. So 4W minus 7 is equal to 2W plus 13. You solve it out, W is equal to 10. My first answer. The next part we want to be able to see here again is being able to identify our angles this time. So it tells me we're looking for X. The variable for X for this one happens to be B. So this angle B right here, which is the first part of this, corresponds to angle R right here. I think the difficulty a lot of you guys had is reading that problem. Not that many of you guys came up. Should have been 49. Right, that little angle in there is 49 if that was confusion. Should have been 49. Okay. I never give you guys decimals. I never give you guys decimals, period. Okay. So setting them equal because they're congruent, 2x plus 9 is equal to 49. You solve out, get x is equal to 20. That's your answer for x. The last part of this as well is given the angle for y, which is D. If I'm looking up at D for this one, it should correspond to T, which is in this upper left or upper right. Setting those two equal to each other, subtracting out 1y, adding 31 to both sides, we get y is equal to 42, which is my answer. Corresponding parts. Correspond the parts to get them congruent. Congruent means equal. Set them equal to each other. Yes. Subtracting 11, that means you subtracted 4. That means you probably got negative. You got negative y equals negative 42. That's what you should have got if you subtracted it that way. You could get negative y, but that's not finishing up the problem because it's asking you to solve for y. So if you got negative y is equal to negative 42, divide both sides by negative 1. Then you subtracted wrong. You subtracted wrong. Yep. You subtracted incorrectly. Okay. Number 18. Okay. Number 18 and 19 are great problems. They are beautiful. I like 18 and 19. 18 is not that hard. 18 is not that hard. You'll see why. Okay. I would hope that you know how to do them. Okay. I can't be any more explicit than knowing how to do those. Okay. First part of these for number 18, you got to be able to recognize that you have 4 different ways. You have vertical angles, supplementary angles, alternate exterior angle, and triangle sum. First one that I want to look up here is angle 1. Angle 1 is definitely the one that you want to look at first. It screams out to me because I can solve for triangle sum here. This is my angle 1. 35 plus my angle 1 plus 36 is equal to 180. That is triangle sum at its best. This gives me an angle of 109. Then what I want you guys to see here next is we're going to take angle 3 now because 1 and 3 are supplementary to each other. So I know that those are supplementary. 109 plus angle 3 is 108. This tells me that angle 3 is 29. This is 29. It makes a vertical angle with V on itself, so this backside is 29. Oh, angle, sorry, 71. Solving for the wrong one. This is 71. So that vertical angle is 71. Last part of this is triangle sum one last time for triangle RUV. 80 plus 71 plus angle 2 is equal to 180. So triangle sum to supplementary to triangle or to vertical to triangle sum. Yes. That's basically what I did. Different order doesn't matter. It's the same thing. What's the difference? What's 1 plus 2 plus 3? 6. What's 3 plus 2 plus 1? What's 1 plus 3 plus 2? No matter what way you get it, you're still getting 6. So no matter what order you put them in, as long as you're adding them, it doesn't matter. Okay. The one to the right should have been very identifiable as well. Last problem on the test, well, you'll have to do this. It is a little bit easier because it provides you more angles, but you still got to know how to be able to apply this idea. The first thing that screamed out to me was that the fact that this was an isosceles triangle here. Isosceles triangle tells me that the angles that hang off of them are congruent. That's why I made those both 67. For this first part, 67, 67 plus the other angle on the upper part would equal to 180. This gave me an angle of 46. I had a 90-degree angle here, which tells me that those are complementary. 46 plus something is equal to 90, which is 44. My last part of this is I know that I have a larger triangle here, which is also isosceles, meaning the angles that hang off of them is 44. This angle must also be 44. Triangle sum for the last part. Highlight that a little bit better. Triangle sum for the last part gives me the last part of this angle. 44 plus 44 plus x is equal to 180, which is equal to 92. Yes. We have an isosceles triangle here. Isosceles triangle strikes again. It's upside down. Gotta be able to identify those and provide me those angles. If I were to basically flip this one around, this one would look something like this. And this one just dropped down would be something like this. Right? Same properties. Then if you're looking, you can't even look at the other one because it's not giving you anything. Questions, comments, concerns on the back four? Can we look at the final problems? Okay, here we go. Here you go. Check those out. Yes, I'll be going over them as well, so please look over them. Again, for those that are still struggling with this stuff, I'll be going over some problems after school today. If you can't make it to after school, I'll be recording this lesson, this one that we're doing today, and I'll be posting it after school, or probably at lunch. Probably I'll be posting this at lunch, so it'll be on your school loop. For those that can't make it to can't make it today after school, I'll probably be posting a YouTube video as well for the problems I cover after school. So there'll be 2 videos posted on my YouTube channel today, okay, for you guys to use. So keep that in mind. The first part of these are straightforward, I think. I'm going to kind of give you what they entail. The first part of this was triangle sum. Meaning that the angles must add up to 180. This is also triangle sum. Angles must add up to 180. The next pair that we're getting down is exterior angle theorem. This is also exterior angle theorem. The bottom 2 are again reviewing from the front, which is isosceles triangle theorem. And the last one is also definitely want to be able to understand how to do those. Definitely want to be able to apply those. Okay. First pair up here tells me that the triangle sums, all angles in a triangle must add up to 180. So I'm getting this 55 angle here, plus x plus 74, which is the other angle, plus 54 is equal to 180. Solving out, x is equal to -3. Now, x is a variable. X can be negative, okay? X can definitely be negative. If you plug it back in and you're given an angle, the angle cannot be negative, right? If you take 3 away from 74, it's 71, right? That's how you want to be able to perceive those. Triangle sum on the one to the right again. We have the angle 30 plus another angle here, which is represented by a symbol, which is 90. 13x minus 5 is the other angle, must add up to 180. Okay, that's all we're doing. We're plugging back in. Again, this just says solve for x. It does not say you need to have a value or a angle measure. Yes. I'm going to cover that. It does matter for that one. Okay. It only works for equilateral triangles. This is an isosceles triangle, so we have two congruent sides. For this one right here, for 22, we use alternate exterior angle theorem. So the sum of the two interior angles, 30, 4x plus 2, 30, 4x plus 2, will be equal to the exterior angle of 8x, or 8 plus 6x, which is right there. Solving out, we're going to get a value of x is equal to 12. That is not our answer. It's asking us to plug into angle A, which I plugged into angle A. 4 times 12 is 48. 48 plus 2 is 50. If you do not have this on your test, it will be considered wrong. If it's asking you for the angle measure, I'm looking for the angle measure. 12 won't cut it. If you just leave it as 12, well, I got the variable. Good for you. It's not what I'm asking for. Okay, read the question. Not that hard to do. Just plug them back in. This one to the right, it's not asking us for a value of x. It's asking us for the angle measure. Doing the same process, we're going to go ahead and add the two interiors. 88, 7 plus 4x. 88, 7 plus 4x. I know that's a W. I apologize. Looking at the exterior angle, 2x, 20x minus 1. Same thing. Solving out, we get x is equal to 6. It's not what it's asking for. It's asking us for the final value, which I plugged back in. 4 times 6 is 24. 24 plus 7 is 31. Okay. Finishing this up, the bottoms actually care for this time, okay? Just because you're given a triangle, don't assume that you're going to equal any of the sides. The problem that we're getting down here, it asks us to solve for RS, so we got to be able to find for the length. One thing that I know about this triangle is it has two congruent sides. Because the angles are congruent in an isosceles triangle theorem, that means the opposite sides are congruent. Because I know that those two are congruent, I could set them equal and solve. 5z minus 8, 4z minus 2 is going to give me z is equal to 6. That's not what it's asking for. It's asking us for RS, which we want to be able to plug back in. RS is 3z plus 12. I'm going to plug in my 6. 18 plus 12 is 30. This is a lot harder problem than what you'll see on the test. It'll be more straightforward than what you see. But you should be able to divulge that information, okay? If I ask you to plug them in, you should be able to do that as well. Plug these bad boys back in. 7 times 6 is 30. 30 minus 8 is 22. 6 times 4 is 24. Minus 2 is 22. Last problem from here, which is 25. it asks you to solve for angle B. One thing that I know about this again is that it's an isosceles triangle. That means the sides are congruent. The angles that hang off of them must also be congruent. I gave them a variable so you guys can see. Just gave them the value of x. Triangle sum theorem tells me that the angles must add up to 180. Solving out, we get both angles are equal to 66. Okay. We did about 3 of these problems on the homework. We've also did several of them on the review. Okay. We've done a lot of these. Okay. But even the homework, the test review, we did a bunch of these. Questions, comments, concerns? Is it helpful that I went over them? Yes. Build a little more confidence, right? Okay. I would highly recommend you have your index card out or a sheet of paper. Okay. Here's what you guys want to have on it. Can I continue? You okay? Kayla, we okay? Okay. Just want to make sure. Those are what you guys want to have down in your note card. Okay. Those are just notes. Those do not give you anything besides that. Okay? Don't just have those. If that's all you have, that's not going to help you. Will it help me? No. I know it's on the test. This is what I'm giving you on it. Okay? Understand what CPCTC is. Know that corresponding parts are congruent, so therefore they're equal. Yes, you will. Sure. One thing that I've noticed, though, if you take a picture of it, you will not look at it again. Let's be honest. If you want to take a picture of it, you can take a picture of it, but more so than likely, you won't look at it again. Okay. I'm just saying. Okay. It's 2 separate things. It's one column and the other. Okay. Know your triangle congruencies. Okay, no side angle, side angle, side angle. Know the ones that do not help you at all. Okay, know the ones that do not help you. So CPCTC, corresponding parts of congruent triangles are congruent. Triangle congruencies right here, know what works, know the good stuff, and also know the bad stuff. Know which ones don't work. Know the bugaboos. Those bugaboos don't work. Complex solving types of problems, knowing the 4 that you know how to use. And the complex solving, the ones that you want to use is supplementary angles, vertical angles, linear pairs, triangle sum, alternate exterior angle theorem. Okay, they're basically the ones that are seen here. Okay. Know triangle sum theorem, know how it is applied. Yes. Don't worry about what it stands for, just know how to apply it. If you know what it means, that's good enough. Okay, but really know how to apply it. What is CPCTC? No. There will be no question on that. Triangle sum theorem tells you that if you're given a triangle, this is A, B, C, that the sum of the angles must add up to 180. Sophia? On your team test, number 15, number 15, 18, and 19. Number 15, 18, and 19, specifically 18 and 19 more so. So I'll put this down for you. I'll put team test 15, 18, 19. I'll just put those for those. The next part for the isosceles triangle theorem is if you're given an isosceles triangle, this is A, B, C. If sides AB is congruent to sides AC, then angle B is congruent to angle C. Want to be able to know how to apply that for those. Equilateral triangle theorem. Several things come up for this one, which is a glory one. I love this one. Equilateral sides, ABC. If sides AB or AC, AB, and BC are congruent, then angle A, angle B, angle C are congruent. What do we know about the angles of a equilateral triangle? 60 degrees. All angles are 60 degrees in an equilateral triangle. Exterior angle theorem. The final one for this one would be that the exterior angle, so if I give you a triangle like that, this would be A, B, C. A plus B, the two interior angles, is equal to the exterior angle C, which is exterior. I don't like that. Now these, I understand. These are what I understand. These are what helps me. Will these help you? Maybe. If you know what they're asking for, then yeah. Okay. If you just have this on your note card tomorrow, this will not help you enough. Okay. These are what hints you should put down. If it was up to me, I would just write down problems that are associated with these. I would write down what helps you, what can you add into triangle congruencies that will help you for angles and sides. If they're vertical angles, you can input an angle. If they share a side, you can input the side. Know the difference of the angles that do not work out, and what does not help you out. Okay. Put in a couple of complex problems. Okay. Okay. I'm going to go ahead and cover some of these problems. Okay. I'm going to keep on going. I'm just going to try to give you guys enough review as much as I can. Okay. They're going to be very similar. They're on the bottom. The bottom two. Those are the complex ones. Are they that much complex? No. Do you have to work at it? Yeah. You definitely have to work at it. Okay, they're not going to be clear. Okay. So if you have a separate sheet of paper, I'm going to go ahead and do a couple of these. I'm going to try to get through as much as I can. I still have about 10 minutes, 9-10 minutes. So I'm going to try to get through as much as I can. Here we go. Okay, if you want to copy that down, I'll give you guys about 30 seconds per problem to copy. This one is very similar to problem number 1. We have not done something like this, but it shouldn't be that hard to do. Sketch then answer. To prove RAT and MED are by angle side angle, given that RT and MD are congruent, what other parts do we need to show congruence? Okay, just by reading that, you don't know what you're asking for. You don't know what you're looking at. Okay, if you draw it out, yes, it will be tremendously helpful. Okay, and you will have to do that tomorrow. Okay, I think it's probably the hardest question on the test because it's not specifically just giving you parts to it. Okay, create two triangles. It doesn't matter which sides as long as they're congruent. Congruent means what? Same. So let's make two same triangles. It doesn't matter what length or sides. angle, side, angle. So two congruent triangles as best as you can. I need to do this by CPCTC. So I want to be able to label them R to A to T. That was my first pair. I'm also going to do it by MED. So M to E, E to D, using my matching parts to them. That's all I know about these two parts of the triangle. The next part that it gives us is it gives us RT and MD are congruent. So RT, so I'm going to go ahead and highlight that in. RT is congruent to MD. So I'm putting in marks and sides that show congruence. Okay, so I'm creating this problem. I'm drawing it out to help me figure it out. This is what you guys have to do tomorrow. Draw out two triangles, put the given information in, and solve, okay? Looking at these two, if we're trying to prove by angle, side, angle, what two parts are we missing? We're missing angles to show congruence. So can someone give me a pair of angles that would be need to be congruent for our first pair? Angle A needs to be there to show angle side. What are we given? Angle side angle. What are we given already? A side. So angle R needs to be congruent with what part of the other triangle? M. That's our first one. Angle R needs to be congruent to angle M. This is acceptable. This would not be acceptable. This would also not be acceptable. Right? I'm looking for everything. Yes. It has to be congruent pairs. R and T can't be congruent. That doesn't help us out solve for this. Okay. Looking at the other pair here, which other pair must be there in order to show side angle side? T. T and angle T needs to be congruent to angle D. Okay, that's the information I'm looking for. Angle side angle, congruent to angle side angle. Okay, you can make them as simple or as complex as you want. It's up to you. Julian, we're okay? You're getting all this? You don't need help tutoring? You don't need help on this? It will be. It will be. If no one comes in, then no. It will just be whatever I've done today. Okay. The next part that I can also give you something, I could tell you that RT is equal to 3x plus 2. And I could tell you MD is equal to 5x plus 7. Could I ask you to solve for a value of x? What would you have to do? RT is 3x plus 2. They're congruent, so how would we solve out? Set them equal and solve. That's the type of problems you're going to see tomorrow. It will give you congruent parts. It will tell you how the triangle is congruent. Your job is to be able to set everything, all the parts equal to each other and solve what it's asking for. Only one. This is CPCTC at its best. Yes. I just went over them. I went over them in the first part of the test. Here's the next one. Copy it down and give you about 30 seconds. Which other part must be equal for ABC to be congruent to MTR? And the essence of what this question is asking for is giving you a side and an angle. So they're asking for specific parts that to show congruence for these. For the first part, in order for us to show angle side angle for this, what are we missing for these two triangles? Another angle. So angle C to angle R. This would be an angle side angle. So angle C with angle R. Signs on the angles don't matter. Dylan, we're good? Okay. That was confidence. It just means angle. It's another way to write an angle. If I'm going to erase these and do the same thing, what would I missing for a side angle side congruence? Another side, right? AB needs to be congruent to MT. If I erase those marks one last time, what am I missing for angle side? Angle B needs to be congruent to angle. So these are question specific. The no-nos for this would be angles need to be congruent. Sides need to be congruent. Angles need to be congruent. Those are bad. Okay, I'm looking for specific notation. You not have that, you're getting it wrong. We've gone over it plenty of times for you guys to be able to tell me how angles and sides are congruent. Yes? Yes? For what? No, it depends on what it's asking for. That's question number 7 on your test. Question specific. You're welcome. Another portion right here. If you guys need help on this, given parts of these, if you're looking at angle congruencies, we can add in any vertical angles. So vertical, 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 sides. This would not be congruent. Side angle side. Side angle side. Sorry, this would be angle side. Not congruent. Let's see that. Side, side, side. Be ready, be prepared. Let's see this.
Oh, we already put shirts up. I'll see
I'll see you tomorrow. I'll see you tomorrow.
I already have.
Okay.